Привет, Odessa. Good afternoon. And welcome to what is certainly the nicest conference I've ever been to. Isn't this amazing? My name is Dylan Beattie, and for the next 45 minutes or so, I'm going to be talking to you about webmasters, full-stack developers, and other legends. This is me talking about me. I am a web developer, a software architect. The reason why I guess I'm talking about this, I built my first web page in 1992, which is a long, long time ago. I have been building websites and building web applications and internet applications for my entire professional working life. And along the way, I have seen lots and lots of trends, of technologies, companies, ideas come and go. Things have sort of risen and fallen. Some of them have stayed around. I've seen some things that were brilliant ideas that never got any traction. I've seen some things that were horrible that everyone is still doing all the time. And so what I want to do with this talk is to basically walk through the history of the web. You know, how did we get to where we are today? I'm assuming this is build stuff. All of us, hands up if you build stuff. Any kind of stuff, yeah. So we build things, and lots of the things we build are web applications, or they are systems that use the web or rely on web technology. And that's what we're going to be talking about. Because the web is an astonishing thing, you know. The web has absolutely revolutionized the world we live in. There are probably people in the room here whose parents met on the web. I mean, they'll tell everyone that they met at a Pearl Jam concert, but the web has been around long enough now that there are people, you know, out there working as developers whose parents would have met on dating websites. It's literally changing the world and stuff. To give you some idea of how much it's changed the world, I'm going to need a volunteer. I need somebody who's done something, you sir. You have done something very bad. Yes. You have, I don't know, you've written a banner advert server using PHP. Or something. It doesn't matter what you did, but you're guilty. You're guilty and we are going to sentence you. But we're going to give you a choice. So there are two scenarios. In the first scenario, you go to jail. We are going to lock you in a cell and you're going to stay there. You cannot have visitors. You're allowed out to go to court, to go to hospital, but you cannot see people. But we're going to let you have an internet connection and you can get deliveries. So you can have your laptop. If you can find someone who will let you work from home, work remotely, you can work. You can have Netflix, email, Skype, broadband, Amazon deliveries, Just Eat, takeaway food. Anything that you can do online, you are allowed to do. But you cannot go outside. You cannot travel. You cannot go anywhere. Alternatively, if you don't like the sound of that, we are going to sentence you to not use the internet anymore. You can go anywhere you like. You are free to travel, you can work, you can make friends, you can have relationships, all these kinds of things. No internet, no email, no smartphone, no online check-in, no Netflix, no YouTube, no streaming, no Spotify. You're not allowed to use the internet at all. If we sentence you to 1 week, which option would you choose? Would you go offline for a week, or would you spend a week in jail? Who would rather spend a week in jail with broadband than a week in the real world with no internet? Yeah? What, 2 weeks? A month? A year? Because the web is amazing. The internet is incredible. It has absolutely transformed our lives. To the extent that a few years ago, I broke my leg in a skiing accident, and I basically didn't go outside except to go to the hospital for like 6 weeks while it was healing. And I was online. I had Skype, I had the web, I could order things. I would order, you know, stuff on Netflix, I'd order movies, I'd order things from Amazon. It was really, really quite an amazing sort of experience to realize just how many things are possible now because we are online, and so are all the services we're interested in, and so are the people we want to talk to. And we have created, you know, this amazing, amazing thing that has changed the world. And it's happened quite recently. The web is around about 25 years old, depending where you measure it from. Now, the sort of history of the projects that ended up being the World Wide Web, there was some work in the 1960s. The department DARPA, the American Defense Research Association, started coming up with this idea about building a network of computers where if one of the computers was knocked out by a nuclear war, the rest of them would be able to still talk to one another. So they come up with this idea of peer-to-peer networking without a sort of centralized server. There's a bunch of work on this. A guy called Bob Metcalfe, who was working at Xerox, invented Ethernet, which is pretty much the same basic protocol that the internet uses today. Ethernet was 1974. Halfway through, Bob Metcalfe got bored of working on Ethernet because he was convinced that when he was typing, his keyboard was reflecting off the ceiling above his desk. And like all good engineers, he stopped doing the thing he's supposed to be doing and he started trying to work out how reflective his ceiling was. And so his boss went to his boss's boss and said, Bob stopped working on Ethernet and we need him to finish it. What can we do? And in a brilliant piece of engineering management, his boss said, go out and buy him an acoustic meter so he can measure the ceiling tiles, and then he'll get bored of that because it's a solved problem. So they did. He went back to Ethernet. The rest is history. Now, I think the internet and the World Wide Web are different things. I think the internet, as we understand it, the really important things that happened there happened in 1982. So in 1982, there were two things. One is that TCP/IP was adopted as the standard for connecting one network to a different network, for internetworking, internet. So universities could talk to companies, could talk to research labs, could talk to the very few private individuals who were wealthy enough or well-connected enough to have the internet at home. The other interesting thing that happened in 1982 was that SMTP, the standard that makes internet email work, and accidentally made spam happen, but that's a different conversation, that was also ratified in 1982. So suddenly, by the end of 1982, we have these two conventions in place that allow people all over the world to basically talk to one another for free. They can send email backwards and forwards, not just within your own company or within your own university, but to different places around the world. And this started a pattern of collaboration that was going to last for, well, to this day and beyond, you know. It's astonishing. And about sort of 10 years after this, the early 1990s, this guy, Tim Berners-Lee, Tim was a scientist who was working at CERN, the nuclear research center in border of France and Switzerland. And basically, Tim started thinking, all the scientists that he works with are publishing papers. They're doing these amazing experiments and research, and they're taking the results, and they are publishing them in journals, which then take time to be printed and come out. And he started thinking it's crazy that you can communicate with people on the other side of the world, but to actually share your research with them, there's no way of using the internet to publish. That is it. That, in a nutshell, is the problem Tim tried to solve. How do you use the internet to publish things? And whilst he was working on this problem, he started thinking about this idea of something called hypermedia. Because one of the problems with publication, if something's been published, you need to know where it is in order to be able to find it. And what Tim wanted to be able to do, lots of scientific research papers build on other papers. They refer to other pieces of work done by other researchers and so on. So there's a sort of form of very old school hypermedia where you get to the end of something, you look at the references, you drive to the library and you say, hey, do you have these? And they go to the stacks on the shelves and they bring those papers out, and you know, it's much easier just clicking on something blue and making it go purple. Much, much easier. And so Tim started thinking about how to turn the internet, or how to use the internet as a platform to create a medium for publishing things. And he invented three things. So who can tell me what are the three things that Tim Berners-Lee created? Three pieces of technology, three standards, if you like. HTTP was one of them. Anybody? Hyperlinks, kind of hyperlinks, is actually URLs, which seems strange. And the third one was HTML. So he invented these three things. HTTP is a transport protocol. It's a way that a client can say to a server, get me this, get me that. It's a way of clients interacting with server systems. HTML is a markup language. HTML allows you to take plain text, ASCII Unicode text, and decorate it. This is a heading. Please put an image here. This is a paragraph. This is a hyperlink. URLs is the interesting one because they're so ubiquitous. You know, when I started putting this talk together, it actually surprised me that anyone invented the URL, because it just seems like such an obvious thing. But until he came along, it wasn't, you know. There was no way of saying, here, one little snappy piece of text that will let you find something from anywhere in the world as long as you're connected to this network. He built on top of things that already existed, of course. The DNS system was already in place. the TCP/IP layer that sits underneath HTTP was already in place. So he's building on layers of previous abstractions. The really clever thing about the way those three standards or those three technologies were developed is that they work independently of one another. So you can use URLs for all kinds of things. Skype, mail to FTP, Gopher, almost anything that you can click on, we can now use URLs to embed. Here is a service, here's how you talk to it, here's where you find it. Markup languages, you don't need hypermedia, you don't even need a network. You can use HTML just to write documents for people to read. And HTTP, anyone who's ever built any systems that use JSON or XML or anything will be very familiar with the fact that you can use HTTP as a transport mechanism, even if the things you're transporting are not markup, not documents. So Tim comes out with these three things and puts a link on, well, he doesn't put a link anywhere because the web doesn't exist yet, but he creates a web browser, a piece of software called worldwideweb.application, which he creates using a computer called a Next Station, which is a little black thing about the size of a pizza box, which is incredibly cool. And he had one of them, and we're going to talk about where all the others went later in the talk, because it's quite interesting. So what he does is he puts a thing up on FTP saying, hey, I built a browser application. Come and download it and look at stuff. Now, one of the really interesting things Tim did at this point is that he proposed that the web was not just for reading things, the web was a publishing technology. There are 4 verbs in HTTP. There's get, there's post, which everyone knows about because we all use them all the time. There's put and there's delete. Built into the absolute core backbone standard that drives the web is a way of reading documents, a way of interacting with them, a way of publishing new ones, and a way of removing them. This is the first of what I think are the big missed opportunities that we're going to be covering today, because it wasn't long before browsers had effectively abandoned put and delete, and they kind of went quiet for about 20 years. And now, in this day and age, you say, I need to put a document on the internet, and you're going to end up in a conversation about whether you should be using WordPress or Umbraco or .NET Nuke or PHP Nuke, because all of these content management systems that we've come up with, they all run on the web. There isn't this idea of you maintain your content, and then when it's finished, you just put it onto a web server somewhere. Very, very simple, lightweight protocol. The reading side of it has become incredibly popular. Put and delete, really not so much. And I think that's interesting, because if you look at the story about why it happened, so, NCSA Mosaic, the first browser, the big thing Mosaic did, so this is really old school, this is like 1992, 93. Mosaic was the first browser that would let you show images alongside text in the same page, and had some fairly rudimentary forms interaction. There's no CSS, there's no JavaScript, there is no interaction, there is no XML HTTP request, there's no WebSockets, there's no WebGL, there's no VR, there's no nothing, but this allows you to read a document, see the images, click on a link, navigate the web. This little thing that was just starting to grow. There's 2 interesting ways that Mosaic lives on to this day. One of them is that the core code for Mosaic was eventually acquired by Microsoft and became what turned into Internet Explorer. That doesn't really exist anymore, but with the latest version Edge, they've rewritten the code base. So there's no longer any active development that evolved from that, but as recently as Internet Explorer 9 and 10, there was still the traces of this original Mosaic code base sitting underneath the hood. The other interesting thing, the interesting way in which Mosaic lives on, is that the chief engineer, the person running the tech team on this, was a guy called Mark Andreessen, who left to start his own company. And he called the company Netscape because it sounded good. But they formed Netscape to build a product that was going to be a Mosaic killer. And they got fed up of saying Mosaic killer, so they shortened it to Mozilla. And so you can see Mozilla Firefox, the Mozilla Foundation. The name of that whole ecosystem dates back to this thing here. They did rather well. Now this is effectively the stack that you are talking about. There is this expression that gets bounced around now, full stack developers. And it's an expression that I think is interesting because it gives you insights into the kind of delusions that the people asking for it are suffering from. Because around this time, I think it was genuinely possible for one individual who worked pretty hard to have absolute inside-out knowledge of every element of the web stack. Static HTML file system. There's no ASP.NET, there's no Java, there's no PHP. There's a thing called the Common Gateway Interface, CGI, but no one's really doing very much with that yet. But basically the publishing stack is static content on a file server, HTTPD, which was a very, very simple web server that just served up static files. Transport Mechanism, which has survived relatively intact for the subsequent 25 years. And Mosaic, the browser, the thing at the top of the stack. You could actually know all of these things. Know them to the extent that if you were confident, you didn't have to test stuff because you knew exactly what was going to happen. It lasted for about 2 or 3 years. Netscape came along. Netscape was astonishing. Netscape took over the world, ended up with Mark Andreessen posing in bare feet on the cover of Time magazine, making an obscene amount of money. This was the first dot-com bubble, 97, 98, 99. And Netscape achieved 2 things. One is it basically took over the world. Suddenly everyone had heard, I need to go out and buy a modem and a computer so I can get on this new internet thing that everyone's talking about because Netscape. The other thing Netscape did, which is kind of unprecedented, or was very unprecedented at the time, Netscape scared Microsoft into giving something away for free. Because Microsoft they sold software. That's all they did. They had grown from a company who sold MS-DOS and BASIC to Windows to Microsoft Office. The idea of Microsoft going, we made this program and we're going to give it to you for nothing was absolutely unthinkable in the mid-1990s. They were the biggest, richest company in the world. And they did it by selling software. And then they realized that this web thing, Microsoft had missed a trick, and they were in serious danger of getting left behind. They couldn't be first to market because Netscape was there already. They couldn't be better than Netscape because Netscape had such a formidable head start in terms of the technology and actually having a working product out there. Which meant the only way Microsoft could compete with Netscape was on price. Netscape cost $50. Hands up anyone in this room who's ever paid money for a web browser. Yeah. It seems crazy. I bought Netscape when it came out, and a couple of years later I bought a thing called Opera, when Opera was still a commercial product. But, this idea, so Netscape came out, they had a 30-day trial that never expired, so lots of people actually never paid for it. But this frightened Microsoft into giving away Internet Explorer. Next thing you know, Netscape are like, well, actually, we should probably just admit that the free trial is going to last forever and no one's paying for this. And so it started a race to the bottom in terms of how browsers, but also how internet companies would make money. And it formed this idea of giving away the software and giving away the content and then trying to monetize it later. And there's a couple of ways you can make money off doing things on the internet. One is to hope someone buys your startup. That's quite a good way of making money. One is to sell advertising. That's what pretty much drives the web as a whole. One is to sell your customers' data. But the model of actually, building a product or creating some content and charging people money for that product or that content is one that stopped having any traction around the time they started giving browsers away and has never really recovered. So we've got Microsoft have got a browser, Netscape have got a browser. The standards still exist. HTML is still, the World Wide Web Consortium are running it pretty, strictly and controlling what's in it. And then Netscape goes and does this. And this is the first shot that was fired in what would become known as the browser wars. Because this was not part of anybody's standard. Netscape went, oh, I know what, the internet needs flashing text. Because, hey, it's annoying, isn't it? It's really annoying. Netscape decided that this would be a really good idea to have blinking text on pages, and Microsoft went, well, if they've got blinking text, we're going to have scrolling text. So they started putting their own tags in, put in a thing called marquee. Suddenly you had 2 browsers which did different things, and people who were building a web page had to test it in 2 different systems. There were people using Netscape who had things that didn't work in Internet Explorer, and people using Internet Explorer would have stuff that didn't work in Netscape. And this was just the beginning. This got absolutely crazy. There was a period of probably 5 or 10 years where to build something would take you Monday, and then you would spend the rest of the week testing it in all of the different browsers to try and work out what worked and what didn't. It was actually pretty horrible. It was a massive waste of a lot of people's time, and a lot of very smart people spent a lot of very frustrated hours going, it works in Internet Explorer, I changed it, and now it doesn't work in Netscape, and now I fix it in Netscape, and now it doesn't work in Internet Explorer. And it got to the point where the document object model, the underlying abstraction, so at this point we've got browsers that are running CSS and running JavaScript and starting to do clever things like maps you can drag by scrolling on them and all sorts of really, really cool things. But Netscape and Internet Explorer have no compatibility whatsoever in terms of how your code interacts with your content, with your document. And so you would see all this code everywhere. The first line of the script would be if document.layers. Because if document.layers returned true, it meant you were on Netscape, and you'd then have 500 lines of code that were just for Netscape. Else, and then you'd have 600 lines of code that were just for Internet Explorer. And so if you found a bug, you'd have to go and see, well, is the bug in the top half or the bottom half or both? It was horrible. It was very, very horrible. Around this time, Netscape made a big mistake, one of the biggest mistakes it is possible to make if you're a successful company. They decided they were going to rewrite from scratch. So Netscape had been acquired by, so you've heard of Time Warner, big media conglomerate, you know, Time Magazine, Warner Brothers Movies, Bugs Bunny, Batman, all that kind of stuff. Huge, huge, huge company. There's a company called AOL, who don't really figure very much anymore. AOL did dial-up internet access, and they gave away free CDs on the covers of magazines and stuff. AOL got so big that AOL bought Time Warner. The people who do Batman and Time Magazine got bought by the people giving away the free CDs with the internet access. It didn't last very long, but one of the things that happened when AOL bought Time Warner was they then bought Netscape. And they said, come on, we need to ship a new product. And they spun off the code into an open source project called Mozilla and said, we're going to rebuild it from scratch. They went dark for 3 years. By the time the next version of Netscape came out, nobody cared. Internet Explorer had basically won. Everyone was using IE version 5, version 6. When Netscape 5 never saw the light of day. Netscape 6 was kind of okay, but no one really cared. Netscape 7, and then they gave up. They were just like, you know, Netscape as a company is dead. The Netscape rewrite code base eventually became Mozilla Firefox, which is good. You know, it's great. Lots of people use it now. But the lesson there is don't rewrite your flagship product if you want your company to survive. The code might make it through the other side, but the company probably won't. So whilst all this is going on, there's a couple of interesting things. I mentioned at the beginning that this guy, Tim Berners-Lee, invented the World Wide Web using a Next station. Very, very powerful Unix-based workstation. The company who were making Next stations were Next Computers, and the CEO of Next Computers is a guy called Steve Jobs, who you might have heard of. Steve started Apple in the late 70s. Steve got kicked out of Apple in 1985 in a hostile takeover. He moved across the street, took a bunch of engineers with him, and started building these little black, high-powered Unix systems. And a couple of them went to CERN, and almost all the rest of them went to a company in Hollywood, in California, who were doing cartoons. They were making movies with these. And Steve Jobs got interested in what was going on with these people who were buying all of his computers, so he went down to see them. And this is the company who became Pixar. And he's like, what are you doing with all these computers? They said, oh, we're making movies. Look, this is something we're working on. This is Tin Toy, and you know, this is Luxo Jr. Look at a little bouncing lamp and all this kind of stuff. And Steve was impressed, and he bought shares in Pixar, and that's what made him his first billionaire, or made him his first $1 billion, was his investment in Pixar, predicated by the fact that they were buying all the Next computers. A couple of years after this happens, the sort of late 90s, 97, I think, some big, complicated restructuring takes place at Apple, and Apple buys Next computers, and effectively takes Steve Jobs and all of the experience that he's had working on these systems, and he becomes the de facto CEO of Apple again. I don't know, it seems incredible now, but in the mid-90s, Apple were a bit of a losing force. They had, you know, beige computers that no one was really using very much. The people who loved them, passionately, but there weren't very many of those people. And the trend was overwhelmingly towards Windows PCs running absolutely everywhere. There'd be someone on Slashdot saying, oh no, this is the year of Linux on the desktop, which they've been saying every year ever since Linux was invented. But it seems incredible now to think that Apple were basically nobody. They were on the way out. Steve Jobs comes back in. Comes out with this. This was the first iMac. There are two things about this that are incredible. One is it's the first computer ever that people actually wanted in their living room because it looked nice. It wasn't beige and it wasn't boxy. It's curved. This one came in blue. Then they came out with different flavors like grape and tangerine and everything. It is an industrial design classic. It is a masterpiece. It had a modem built in, and it did not have a floppy disk drive. And people went, how can you have a computer without a floppy disk drive? How are you going to save your files? And Apple said, you don't need to save your files. You can email them to people. You can upload them. You can transfer them using the modem. Which, you know, I mean, how many people here have got a floppy disk drive in their machine now? Yeah. One or two? Do you know if it still works? No. I got one. It's full of dust. I have no idea what would happen if I actually tried to use it. But you know, this was incredible. And it was also setting a benchmark for Apple pioneering by doing things that people said you weren't allowed to do. So they come up with this machine. It's a computer without a floppy disk drive. Everyone says you can't do that. It's a massive success. A few years after this, they came out with a music player that didn't have a changeable battery or removable storage. And people said, you know, nobody wants that. Nobody wants a music player that you can't change the battery. But of course they did. It was the iPod. It was a massive success. A few years after that, they came out with a phone that didn't have a keyboard. And people said, you can't do that. No one is going to buy a phone that doesn't have a keyboard. And of course, has anyone in here got a phone with a keyboard now? BlackBerry? Nokia. So, you know, they established this precedent for saying, we are going to get rid of this piece of legacy technology because everyone else still thinks it's important, but we're thinking a year ahead of where everyone else is now, and we are going to start dumping these bits of technology that are actually unnecessary. So this thing comes out. In short order, Apple delivered their own browser, a thing called Safari. Shortly after that, actually it was about the same time, they come out with a new operating system, OS X. So OS X takes all of the usability refinements that they'd built with the old versions of the Apple operating system, but it takes the Unix kernel that was used on the next systems. And suddenly, people all over the world are actually running industrial strength Unix kernels in a machine with a decent user interface and a decent browser on it. Prior to this, Macs had run a version of Internet Explorer that everyone hated, and that it was the absolute bane of your existence. If you were building websites, you would get something working in all the browsers, and then you get a phone call from the client, and they'd be like, it doesn't work. And you'd be like, we've tested it in everything. What are you using? And he says, I'm using Internet Explorer 5.1 on a Power Mac. And you'd be like, oh, crap, there goes my weekend. Because first you'd have to borrow a Power Mac, and then you'd have to spend the whole weekend debugging code that didn't work in it. So Safari's a massive step forward in terms of getting, you know, Mac up to parity. Now, as I've mentioned over the last few minutes, all of these different browsers have different capabilities. They support different functions. They've got different object models. They implement the same CSS rule to do different things. This book was the Bible for anyone building websites around this time. It's about 2 inches thick, and it's the most boring book in the world ever to read, because what it does is it takes every single JavaScript function, every single tag, every single CSS rule, and it just lists in a big table which version of that tag does what on which browser. And so if you had to implement something, you'd grab this book, you'd flick to the right page, and you'd be like, okay, need to do this, need to do this, need to do this, need to do this. This got very, very tedious, as you can probably imagine. And so someone had the bright idea, hey, why don't we make a framework that takes all of these different things and it puts a consistent model across the top of them. Basically, let's create a level playing field. I think the first thing to do this was a thing called Prototype. Then there was Mood Tools. Then there was Scriptaculous. The one that really nailed it, you know, got it absolutely right, was jQuery, which I'm sure everyone here is familiar with if you do web development. jQuery did a couple of really good things. One is it gave you a consistent programming model for implementing behavior that worked on Internet Explorer 7, 8, Netscape, Firefox, Safari, Google Chrome, which had also come out of nowhere at this point with a lovely little comic explaining why it was so good, if anyone remembers that. And so jQuery came along and effectively gave you a level playing field. Suddenly, you could actually write applications instead of just debugging cross-browser rendering bugs again. Now, the interesting thing about that is that since that happened, most of those browser quirks have gone away. Nowadays, Internet Explorer 9 and 10, and certainly the new Microsoft Edge browser that they're shipping with Windows 10, have pretty much 100% support for the latest versions of these standards. Firefox does, Google Chrome does, Safari does. They're all based on the core thing called the WebKit rendering engine. Opera does. So the reason why everyone started using frameworks in the first place was that if you didn't, you would spend your entire weekend fixing cross-browser issues. The cross-browser issues have kind of gone away. But it's become, this idea that you need a framework to do things has become so embedded into the way so many developers think about what they're doing, that almost the first step to, I need to build an application, okay, what framework am I going to use? So this is a challenge to all of you. Next time you're building something, try and just write it. Write some code. Don't worry about getting this framework plugged into that framework, plugged into that grid system. Think about the problem you're trying to solve. Think about what it is that your clients want you to do. What is the value you're trying to create? And think, do you actually need to plug a framework in? Because once you start working with frameworks, as well as understanding what the core technology does and understanding what your product does, you have to understand your frameworks. And you have to understand the dependencies. And you have to understand the dependencies. And then one day you find out that you're using a build chain which uses Node.js, which uses something called LeftPad, and the person who wrote LeftPad has just got upset. And they have taken it off the internet. And thousands of developers are like, none of my stuff works anymore. I can't even build my project. I can't ship bug fixes. I can't release anything, and I don't know why. And they do a little bit of digging, and they discover that it's because their code is using Grunt or Gulp or Bower, and these things are built on top of Node. Now, Node.js basically took the JavaScript engine that was running in the browser and ran it on a server. It was one half of a really good idea, and I don't think the second half ever really happened. Because most languages come with a runtime library that does things for you. If you're running .NET, you have C# or F# or Visual Basic if you're into that, and you have the .NET runtime, which gives you this big library of classes to do things like strings and arithmetic and random number generation. If you're using Java, you've got the Java runtime environment and the Java virtual machine, all the core classes there. C comes with the standard library for that. Almost every mature development environment comes with a standard library of useful functions, except JavaScript. Because JavaScript was originally designed to run in a browser, and it has this ethos that I always kind of liked of whatever your runtime platform is, that's going to expose the objects that you're manipulating, and you're going to use JavaScript to glue them together. So when they started running JavaScript on servers and JavaScript on workstations as part of your development environment, there's a lot of things missing. And by this point, this idea of using frameworks and modules to solve problems instead of writing them had become so entrenched that people downloaded a module that padded a string. You know, this is something most people could write with one hand while they're drunk. But people didn't. They just download. This is the mindset that surrounded the sort of whole Node and NPM world. And so when this package got taken away, it broke. And for a lot of people, that was the first time they thought, holy crap, you know, I think I own this product. I think that I have control over my release process, but actually I'm depending on all sorts of things. Have you ever, I did this just recently, I checked out a bunch of code from GitHub at the airport, got on a plane, went to do some work, and realized that I couldn't because the first step in my build process was to download all of the NuGet packages that my project requires, and no internet on the plane. And so all the stuff I was planning to get done on the flight is like this close. Like it's that one extra step. And it's about understanding those dependencies. You know, if you have build pipelines on your projects or where you work that take hits on other things, dependencies, package libraries, build chains, think about what would happen if they went away. Think about the extent to which you actually have control over them. And so we're going to wrap up just with a sort of quick recap of the ideas and principles and bits and pieces we've talked about. As you know, the title of the talk today is Webmasters, Full Stack Developers, and Other Legends. Now, I think I'm playing devil's advocate. I think it's reasonable to expect somebody to understand something about every layer of that stack. But I showed a slide earlier on with, you know, there's 4 layers in the stack: the browser, the transport, server, storage. Nowadays, you have the browser, except the browser is probably going through an intermediate caching layer. Behind that, there's a content delivery network. The browser will have JavaScript and probably some JavaScript frameworks, and you've got CSS, except the CSS isn't being written by hand, it's probably being generated by Less or Sass or one of these libraries. And then when you get onto the transport layer, you've got HTTP, but you've also got Speedy, and you've probably got TLS, and you've also got content being pulled in from content delivery networks. You've got incredibly sophisticated caching directives going on in the way HTTP and documents and things will interact. You've got XML, and you've got JSON, and you've got streaming media, and you've got real-time streaming protocols, and you've got buffered interrupts, and you've got the idea of partial downloads and resuming. That's just the transport layer. You get onto what's actually running on the servers. .NET 1, 2.1, .NET 3.5, .NET 4, .NET 4.5, Java, PHP, Node.js, Erlang, all of these incredible languages. You know, I think you take any one application and look at the actual stack, every piece of technology between the data where the value is and the user who wants to get at that data. And I think you get to a point where for lots of applications, it's unrealistic to expect one person to really understand the pitfalls of every level of that stack. So why don't we take the approach of simplifying the thing, stripping it back down, and going back to that very simple model. I was talking with someone the other night about BuzzFeed, or any of these companies who basically publish link-bait content. And they have to employ loads of engineers, and the engineers run the virtualization infrastructure that drives the content delivery networks for the advertising that pays the revenue. And the reason they need the advertising revenue is that they need to make enough money to pay the team of engineers to manage the infrastructure that manages the advertising. It's like if you took all the adverts off BuzzFeed, you probably need one person with one server to just put articles on the web, And there's a lot of things like that. Twitter, which has this amazing, Twitter is 140 characters, it's tiny. But if you actually look at what is in one tweet when you view it in a web browser, it's nearly 2 megabytes because of all of the JavaScript and the tracking and the interaction and all of the other stuff that's going on there. And so maybe we have started, taking cheap bandwidth and the fact that everyone's connected all the time for granted, and we just throw away or throw data around without caring about what it costs or what the impact is. So just to recap, Tim Berners-Lee, simple components. HTML, nice, simple, works. Went a bit funny during the browser wars, but now I think it's pretty much back on track. HTML5 is quite nice. HTTP, 1.1. HTTP 2.0 is floating around, but 1.1 works incredibly well. It's easy, it's simple to understand, it does the job. URLs are ubiquitous and brilliant and never going to go away. The phrase .com has become completely ubiquitous in business, in industry, everywhere, thanks to URLs. Innovation can mean taking something away. Take a computer, take out the floppy disk drive. Take a phone, remove the keyboard. Take your stack and go, why don't we dump the banner advertising and the JavaScript tracking cookies and the content delivery network? Think about whether you can actually deliver a better user experience and a better product by getting rid of something that everyone else is telling you has to be there because that's the way you've always done it. Don't rewrite your product if you want your company to survive. Your company has to be seen to be doing stuff. It cannot go dark. You go dark for 3 years in the internet age, you're never coming back. Your code might escape via the back door, your engineers will go and find jobs somewhere else, but your company will be toast. Learn from Netscape's mistake and do not do this. Remember why you're using frameworks. Back when browsers were all completely incompatible, frameworks made a great deal of sense. Nowadays, don't just go, ooh, project, right, grab this, grab Bootstrap, grab that. Look at the problem. What is it you're actually trying to do? What is the problem you are trying to solve? If you get to a point where you decide a framework actually is the right solution to that problem, go for it. There's lots to choose from. But you don't necessarily need to go for one. Remember why the things in your chain have become part of what they're there for. Understand your dependencies. Every time you include a library or a module or something else from an open source repository, from a package repository, understand what it is. Have a plan for what you would do if that dependency went away. Could you re-implement it yourself? Do you have a copy somewhere on a caching proxy? Have you got local copies of all of your package dependencies? But understand the extent to which other people's code and other people's systems have formed a key part of what it is that you're trying to achieve. And remember, this is the stack that changed the world. This is the stack that got people online. This is the stack that got people reading documents. This is the stack that has effectively given anybody with a smartphone or a broadband connection or a dial-up connection one-click access to almost the entire total of human knowledge that has ever been written down. Thank you.